Here's an uncomfortable little fact. On a huge number of websites, the thing that decides whether you get in or whether the whole database walks out the door is a single line of text, the login box. You type your username, you type your password, and you hit enter. Simple, except that behind that box, the application is quietly turning whatever you typed into a command and handing that command to a database. And if it builds that command carelessly, then your typing is no longer just data. It becomes part of the instructions. Type the right characters in the wrong field, and the question the app meant to ask, "Am I allowed in?" silently turns into a different question entirely, one that answers yes to everyone. No stolen password, no cracked encryption, just text in a box that the database mistook for a command. This is SQL Injection, spelled SQL, often said SQL Injection. And by the end of this video, you will understand exactly why it happens, and the one technique that makes it almost impossible. So let us start at the box. Let us be concrete and follow one single example all the way through. Picture an ordinary login form. 2 fields, a username, and a password. To you, this is just a form, but to the application, every character you type is untrusted input. That word, untrusted, is the whole mindset. It does not mean the app thinks you're a criminal. It means the app cannot assume anything about what is in that box. It might be a normal name, it might be empty, or it might be carefully crafted text designed to mean something to the machinery underneath. A search box, a comment field, a sign-up form, a URL with an ID in it, they are all the same shape. A place where input from the outside world flows inward toward something powerful. And the most powerful thing it can reach is the database. So the real question of this whole video is simple. When your text leaves that box and travels inward, what exactly is it allowed to touch? Behind the login box sits a database, and the language the app uses to talk to it is SQL, the structured query language. Think of SQL as a precise sentence. The app wants to ask, find me the user whose name equals, and then your username, and whose password equals, and then your password. That sentence has 2 kinds of pieces inside it, and this distinction is the entire video. There are instructions, the verbs and the grammar, words like select, and from, and where, and equals, the parts that tell the database what to do. And there are values, the actual data, like the specific name and password you typed. In a healthy system, those 2 are kept strictly apart. The instructions are fixed and written by the developer. The values are just inert content that gets slotted into place. Code on one side, data on the other. A clean, bright line between them. Hold that line in your mind, because the entire vulnerability is the story of that line being erased. So how does the line get erased? Here is the original sin, and it is astonishingly common. To build that SQL sentence, a developer takes the fixed instruction text and simply glues your input directly into the middle of it as raw text to make one long string. This is called string concatenation, and it feels completely natural. You have a template where name equals quote, and you paste the username right there in the gap, then close the quote. For a normal name, it works perfectly, and that is exactly why it survives in code for years. But look closely at what just happened. Your input and the app's instructions are now living inside one single string with no wall between them. The database does not receive code and data as 2 separate things. It receives one finished sentence, and it has no idea which parts the developer wrote and which parts a stranger typed. The bright line is gone. Everything is just text now, and the database trusts the whole sentence equally. Now we arrive at the heart of it. Why is gluing text together so dangerous? Because some characters are not just letters. To the database, certain symbols are punctuation, grammar, the marks that separate one part of the sentence from another. A quote mark, for instance, tells the database the data value ends here. So imagine the input is not a plain name, but text that includes a quote mark, followed by more SQL. The quote closes the data value early, and suddenly everything after it is sitting outside the data in the position where instructions live. The database, reading left to right, has no way to know that part came from a login box. It just sees grammar and it obeys. This is the data code boundary collapsing. Input that was supposed to be inert content has crossed over and become live instructions. That is the formal definition of injection. Untrusted data is interpreted as code. The attacker did not break into the database. They simply spoke its language in a field where only data was expected. Let me show you the single most famous shape of this, conceptually, because it makes the idea click. Remember the login query? Find the user where the name matches and the password matches. The classic trick is to supply input that, once glued in, closes the value early and then adds a small piece of logic that is always true. You have probably seen the phrase, or 1 equals 1. 1 always equals 1. So now the database is no longer asked, is this exact password correct? It is asked, is the password correct, or is 1 equal to 1? And since 1 is always equal to 1, the whole condition is true for every row. The careful check the developer wrote has been quietly rewritten into a check that can never fail. That is the entire magic trick. Not guessing the password, not stealing it, changing the meaning of the question, so the password stops mattering at all. The lock is still there. The attacker just rephrased what counts as the right key. So why do security people treat this as one of the most serious bugs there is? Because once your input can become instructions, the consequences fan out fast. Conceptually, an attacker who can change the meaning of a query may be able to bypass that login entirely. Walking in as a real user with no valid password, they may be able to read data they were never meant to see, reaching into tables the app never intended to expose, customer records, other people's information, internal data. They may be able to modify or delete data, quietly changing or destroying what is stored. In some cases, the foothold reaches beyond the database itself. The official catalog of software weaknesses files all of this under CWE 89 and lists exactly these impacts: lost confidentiality, broken integrity, and bypassed authentication. One careless string, and the database stops being a vault and becomes an open question that anyone can rephrase. Before we fix it, let us clear up 3 things people get wrong, because the corrections matter more than the trivia. First, injection is not only about SQL. SQL injection is the most famous example, but the same flaw appears anywhere untrusted input is fed into an interpreter as code, operating system commands, LDAP, and more. In fact, in the OWASP Top 10, the industry's reference list of web risks, injection is a single broad category, a 03 in the 2021 edition, that even absorbed cross-site scripting. Second, this is not some rare, exotic bug. It is decades old, thoroughly documented, and still routinely found, precisely because that string gluing pattern is so natural to write. And third, the big one, the problem was never your input. Filtering out scary words is a losing game of whack-a-mole. The real problem is the architecture that let data and code share one string in the first place. Fix the architecture and the scary words stop mattering. So what is the wrong way to fix it? The tempting instinct is to clean the input. If a quote mark is dangerous, just hunt down every quote and neutralize it before building the string. This is called escaping, and here is the trap. It can work, but it is fragile. You are now responsible for perfectly anticipating every special character in every database, in every situation, forever, and getting it right every single time. OWASP is blunt about this. Escaping is strongly discouraged as a primary defense. They cannot guarantee it stops every injection in every case, because you are still building one mixed string and merely hoping you sanitized it well enough. It is a patch over the real flaw, not a cure. The data and the code are still tangled together in the same sentence. You have just promised to comb the tangle carefully. The right fix does not comb the tangle. It refuses to tangle them in the first place. Here is the actual cure, and it's beautifully simple in spirit. It is called a parameterized query, also known as a prepared statement. Instead of gluing your input into the sentence, the developer writes the SQL instructions first, completely with empty slots where the values go, little placeholders. The database is handed that template and it locks in the structure of the command, the grammar, the meaning, before your input is anywhere near it. Then, separately, your actual values are passed in to fill those slots. And this is the crucial part. A value that arrives through a slot is treated as pure data, always. It can never be read as grammar, never as an instruction, no matter what characters it contains. OWASP puts it exactly. The database will always distinguish between code and data, regardless of what user input is supplied. The bright line we drew at the start, parameterization, is what makes that line real and unbreakable. The code is decided first. The data arrives second and stays data. Let us be precise about why this works, because it is not just sanitizing in disguise. With escaping, you build the full sentence and then try to scrub the dangerous bits out of it. With a parameterized query, the sentence's structure is finalized before the data ever shows up. So go back to our trick, the input with the quote mark and the always true logic. Feed that exact same input into a parameterized login query, and nothing happens. The quote mark does not close anything. The or 1 equals 1 is not read as logic. The whole thing is simply taken in its entirety as one literal username, a username that happens to contain some funny characters and that no account has. The database faithfully looks for a user literally named that, finds nobody, and denies the login. The attack did not get neutralized. It never became an attack at all because it never got to be code. That is the difference between cleaning a wound and never getting cut. Now, an honest caution, because this is where overconfidence creeps in. You might be thinking, I use a big framework, or an ORM, an object relational mapper, that writes the SQL for me, so surely I am safe. Mostly, yes, and that is wonderful. Modern frameworks parameterize by default, which is exactly why you should prefer well-vetted libraries over hand-built queries. But automatically is not the same as always. The moment a developer drops down to a raw query or builds a fragment of SQL by gluing in a string, even inside a fancy ORM, the door reopens. And here is one that surprises people. Stored procedures, code that lives inside the database, are not automatically safe either. If a stored procedure builds its own query by concatenating input, it is just as vulnerable. The lesson is not trust the tool blindly. It is understand what the tool is doing and make sure that, somewhere, the values are truly being kept separate from the code. Parameterized queries are the primary defense, the one that actually closes the hole. But good security never leans on a single wall, so let us layer a few more behind it, the way OWASP recommends. First, allow list input validation. Decide what valid input actually looks like. An email should look like an email, an ID should be a number, and reject anything that does not fit. This is not a substitute for parameterization, it is a second filter in front of it. Second, least privilege. The account the app uses to talk to the database should be able to do only what it genuinely needs, and nothing more, so that even a mistake does limited damage. Third, prefer those vetted frameworks and prepared statements everywhere by default. And a web application firewall can sit out front as a backstop, catching obvious attempts, but never, ever as a replacement for fixing the code. Defense in depth means parameterize first, and then stack the other layers behind it. So let us bring it all the way home. SQL injection is not really about databases, or hackers, or scary symbols. At its core, it is about one bright line, the line between code and data. When an application builds its commands by gluing untrusted input into a string, that line gets erased, and text that was supposed to be inert content quietly becomes instructions. A login box stops asking, "Do you know the password?" and starts asking a question that is always true. The fix is not to scrub the input harder. It is to make the line unbreakable, to decide the code first, and let the data arrive afterward as nothing but data. Parameterized queries. Least privilege. Vetted tools. Validate what comes in. That is the whole defense, and it has not changed in decades. So the next time you see a humble login box, remember what is really being decided behind it, and whether anyone drew that bright line. If this made injection finally click, consider subscribing, and I will see you in the next breakdown.